Hello guys, welcome back again to Guru. Uh Today guys, I'm moving on with measurement. So today the focus is going to be on the area. Yesterday I posted a video, it was about perimeter. So if you want to know what is the perimeter, how we calculate the perimeter of different shapes, go and check it out. And then if you still want to know what it means when we talk about the perimeter, you can go and check it out. Okay, and then bear in mind that in few weeks time I will be now doing live videos whereby I will be treating previous question papers, both paper 1 and paper 2, so that people can prepare for mid-year exams. Okay, both accounting and maths lit. Okay, right. Without any waste of time, let's juggle on and see what is an area now, because our focus for today is on area. Okay. Oh, is my pen not moving today? What is happening? Is my pen in? Good. Okay. Yes, my pen is in. So today our focus is going to be on area. Okay, so the first thing that we'll need to do, we need to understand the definition of an area, so that when we move forward we know exactly what we are going to calculate. Okay, so when we talk about the area, we talk about the surface that is enclosed by the 2D perimeters, meaning that now if we want to compare the difference between the perimeter and the area, we know that the perimeter is the area, the total distance around the object. But now we're going to talk about the enclosed surface that is surrounded by the perimeter. Okay, so we can say the area is the enclosed surface, enclosed surface by perimeter. Okay, and then the units used in area, units used in area is millimeter squared, centimeter squared, meter squared, and kilometer squared. Okay, so I have taken you through how to convert. That is, I have a lesson, you go and check it out. I've also taken you around the perimeter, so now we can also see that the units in the perimeters now, they're no longer going to be the same. But remember, we are talking about same units, the units that we use to calculate the distance or to measure the distance. Okay, so in perimeter we only worked with millimeter, centimeter, meter, and kilometers. But in the area, something different, whereby we're going to talk about now millimeter squared, centimeter squared, meter squared, and kilometer squared. I will show you how they become centimeter squared, millimeter squared, or kilometer squared. Okay, now we are still going to focus on our shapes. All right, so okay, we're gonna have shapes here, and then we're gonna have formula to calculate area. We want to see how we calculate the area of all our shapes. So we'll be doing examples as well. Okay, right, shape number 1, we're going to start with the square. my drawings, I know that my drawing is not going to be accurate. I know that one. But what matters here is that for us to say a shape is a square, we know that all sides are equal. Okay? Look at this. Right, so our shape here is a square. So what matters here, the most important thing is to check how do we calculate an area of a square. Okay, remember we said the area is the enclosed surface by the perimeter. So we're talking about the space in between of this object. You understand? The space surrounded by the perimeter. That's what we talk about. Okay. So how do we calculate that space? We're gonna say side by side, or someone can say the area of a square is calculated by saying length times breadth. Okay. Now let me give you an example. For example, remember in a square we don't need to be given all the sides. If we are given one side, we can be able to know the dimensions of the remaining three sides. Okay, so we only need to know how much is our length. If our length in this case is 5 centimeters and we need to calculate our area, so what are we going to say? We're going to say area is equals to 5 centimeters multiplied by 5 centimeters, which is now on your calculator. You're not going to punch 5 centimeters. Okay, you are only going to punch 5 multiplied by 5. Okay, 5 multiplied by 5, that is going to become 25. Okay, so what about centimeters multiplied by centimeters? Okay, so we're gonna go to the basic of mathematics right now, the one that was done in grade 8 and grade 9, whereby you were taught about the exponent and the base. Okay, so any number is to the power 1. So the rules of math says if the base are the same, we add the exponents. Okay, so our base in this case is centimeter and centimeter, and our exponent is 1 and 1. So what are we going to do? We write 1 base and then we add our exponent. So this is going to be centimeter to the power 2. That means our answer here is 25 centimeter squared. Okay, now our answer should be in one of these units. If our answer is in one of those units, that means our answer is correct. Okay, and now if your answer, you have only written 25 centimeters, that means you are not calculating the area, because the area, it says the units has to be in unit squared. Okay, so in this case we can see that with the example that we have calculated the area, and our area is 25 centimeters squared, meaning that we are correct. Okay, so we can move on to the next one. So when we move to the next one, we're going to do a different shape. Now we're going to do the different shape. Right, when we move forward now, we're gonna have another shape. Another shape like this. This side is equal to this side, and this side is equals to this side. That is our rectangle, which says that how do we know that the shape is a rectangle? Because two opposite sides are equal. That is where now we can confirm that our shape here is a rectangle, right? Is a rectangle. Okay, so how do we calculate the area of a rectangle? Okay, area of a rectangle, it has a formula which is fixed. Okay, so these formulas that I'm giving you, they are fixed, they cannot be changed, they cannot be added. But in the exam, sometimes when they give you some combined shapes, they can try to summarize the formulas, okay, to add formulas. Actually, if they can see that a shape is formed of a rectangle and a circle, they can try to combine the formulas and form one formula. Okay, so you must know your boundaries. You must know that every time when you deal with a rectangle, your formula to calculate the area, it says length times breadth, so that you can calculate the enclosed surface. Okay, the enclosed surface. Now let's also do an example. So in this case, in order for you to let me do this. I want to do this. Right. Remember, with the square, you're only looking for one side. So if you have one side, you can calculate the area, okay? But when you have the rectangle, you cannot calculate. When you have the rectangle, you cannot be given one side and then to calculate the area, okay? You must, it is a must that your examiner or whoever have started the question paper must give us the dimension of the length and the breadth. We don't have to measure them with our rulers, unless stated so that we must measure the length and the breadth so that we calculate the area of that object. But if the examiner doesn't say so, that means the examiner must give you the length and the breadth. Okay, let's say for instance here you are given 50 centimeters, and then here you are given 300 millimeters. Okay, and then the question comes, it says calculate the area in centimeters squared. Okay, so if you check here, the dimensions that are given, your length is given in centimeters and then your breadth is given in millimeters. Okay, so now you must go with the equation. Remember, the units must be the same. You cannot multiply centimeters by millimeters. Okay, so you must have same units. If you work with the centimeters, you must have centimeters in your dimensions. If you work with the millimeters, you must have millimeters in your dimensions. All right, so in this case, you must listen to your question. Your question says calculate the area in centimeters. It means that we must leave 50 centimeters alone and we must convert our width here, which is equals to 300 millimeters. Okay, so if you go and check out the video of convention, then you'll understand how we convert. Okay, so now we're going to check the relationship between centimeters and millimeters. According to the metric system, it says 1 centimeter is equals to 10 millimeters. That's the metric system. Okay, so we're gonna do this. So this is our right, this is our left. So we are given 300 millimeters, meaning that we are given the right hand side. So we're gonna write 300 millimeters. Then here we write the question mark. Okay, then we cross multiply. So it's going to be the question mark multiplied by 10. That's going to be 10 question mark, which is equals to 300 multiplied by 1, that is 300. Then we need our missing value, which is the question mark. Then we divide by 10. Then we divide here by 10. So we'll end up having this one. We'll cancel this one. Then we are remaining with 30. Then we know that the question mark represents centimeters, meaning that this is 30 centimeters. And then this is our breadth. Okay, now when we go to our formula now to substitute, we're going to say our length is 50 centimeters multiplied by the breadth of 30 centimeters. Okay, so that's going to be 1500 centimeter squared. That is our area of this rectangle. Okay, I hope that is so understandable. Then we're gonna move to the next one, which is now our circle. So when I'm going to do the circle here, I'm going to do them concurrently, meaning that I'm going to deal with the semicircle, I'm going to deal with the circle at the same time, because the two are different. One is a full circle and one is half of a circle, so I'm going to deal with them concurrently. Okay, they all fall under a circle. Right, let me do this again. Right, let me change the color. Let me opt for this one, or let me take this one. Okay, right. So now let's hope that today I'm going to draw a nice right, a circle. Then I'm going to draw half of a circle here. Okay, so this is a semi circle. Okay, so how do we calculate the area of a circle? Area of a circle is calculated by saying area is equals to pi r squared. Okay, so this formula is to calculate the area of a full circle. Okay, so how can we then calculate the area of a half of a circle? We can say the area is equals to pi r squared divided by 2, because this formula is to calculate if an area of a full circle, and then here we'll need what, the area of a semicircle, meaning that we can divide that by 2 so that we get half of that circle. Okay, right, now we're gonna do an example. Let's say we are given a diameter of 30 centimeters, and they say we must calculate the area. Remember guys, with the circle, they must tell you how much is the radius, or they must tell you how much is the diameter. If they don't give you any of these two, you cannot calculate the area of the circle, meaning that when you have when the question talks about the circle, now you know that you must look for a diameter or the radius. Okay, now we have a diameter of 30 centimeters, but in our formula here the diameter doesn't fit in. Okay, we cannot use our diameter to calculate the area of a circle. So what are we going to do? We are forced to start by calculating the radius of that diameter. Okay, so we know that radius is equals to diameter divided by 2. Okay, which is going to be, a diameter is 30 centimeter, then we're going to divide our 30 centimeter by 2, meaning that our radius is 15 centimeters. Okay, now we're going to substitute now, because we want to calculate the area of a full circle. Okay, so an area of a full circle, it says pi r squared. Okay, now we're going to substitute, whereby our pi is 3,142. Now we're going to open the brackets, and then now we need to know how much is our radius. Our radius is 15 centimeters. Then we are now going to square 15 centimeters. Then we're going to have 3,142. I didn't write 142. 142 here. Okay, multiply by, then 15 to the power 2, 15 to the power 2 is the same as saying 15 multiplied by 15, okay? Which is going to be 225. That means now we have now squared 15. That is 225. Then what about the centimeter now? The centimeters, we also square them, okay? Meaning that all of this is going to be 225 centimeters squared, which is equals to, which is now 706,95 centimeter squared. And remember, I said all our answers should be in units squared, so we need to confirm that your units used units used in areas, they must be millimeter squared or centimeter squared or meter squared, okay? So we can see that our answer is centimeter squared, meaning that we have calculated the correct answer, okay? Now let's say we want to now to make this a semicircle. Let's say this was a semicircle with the same diameter, meaning that the radius is also going to be 15. So if we wanted the area of the semicircle with a radius of 15 centimeters, it means that we're going to divide here by 2 so that we can get the area of a semicircle. Okay. Right, I'm going to jump to another one here. Let me give you one second to look on that. Okay, right. The next thing that we are going to do now, we're going to check another shape. We're going to check our triangle, okay? With the triangle, I want to try and then do something else, but I don't know if people will. But let me make it understandable, okay? Let me choose another color here. Yeah, let me choose green. Okay, right, we're gonna have our triangle like this. Our triangle like that. I'm going to play around with it. I'm going to play around with it, and then we'll check this side. We're gonna have the formula, okay? So here we can see, okay, I wanted to do something else. Let me see if I remove this, okay, so that I can do it this way, okay? Yeah, so this side we have the base, and then this side we have the height. This side we call it the height, okay? Now I want to take people for a ride. Now I want to do this. I want to throw my square here. I want to throw my square, and I want to do this. Can I please draw nicely here and throw this and throw this, okay? So if you observe our square here, and then I'm going to emphasize something here, okay? I'm going to emphasize that let's remember how we calculate the area of a square. It is the area is equals to length times breadth, okay? So now if this is our length, this is our breadth, but remember everything is the same here. Now I want to show people something here. If I draw this line again here, it means that in this square we are having 4 right angle triangles. We have 4 of them, Okay, then in this triangle, look at them. How many right angle triangles do we have? We have two of them. It means that if we take this area of a square and we divide it by 2, we will end up having the area of a triangle. I'm repeating. If let's say this side is 5 centimeters, then this side is 5 centimeters. We want to calculate the area of this, okay? So it's going to be 5 multiplied by 5, meaning that the area is equals to 25 centimeter squared. And I'm saying if we divide this by 2, we will get how much? 25 divided by 2, that will be 12.5 centimeter squared. Let's leave it that side. I will show you a beautiful story about that. Okay, and remember, if our height here, if this is the height, it means that this height now is going to be 5 centimeters. Okay, so what I'm saying is that 4 right angle triangles, they make a square. I repeat, 4 right angles triangle, they make a square, meaning that if we take 2 right angles from our square, if we take 2 right angle triangle from our square, they're going to form a triangle. So how can we calculate the triangle, the area of this? Let me show you a beautiful thing here. The area now, we are no longer going to say we take full of this. We are no longer going to take this line, because if you check, let me get a different color so that I want to highlight something, because we are only talking about this color that is going to be painted with orange here. Let me increase the scale here. All right. Right, we are talking about this one, and this one. Look, this is our 2 right angle triangles. These ones. Let me reduce my scale, and let me go back here, and then let me. Okay, so I'm saying the square is made of 4 right angles triangle, and then what do we need here? We need the area of a right angle. So now, instead of taking this length the way it is, and then now when we go to the right angle, to the triangle, we no longer call this a length, we call it what? A base. Okay, and then look at this, look on top there. Look on top. Our line, yes, is full here. But when we look on top, we are no longer having the same line. We are no longer having that line, because look on top. We don't have this line on top, meaning that we are only going to take one. That means we're going to take this base. Let me see. My line is too thick. Okay. We're going to say half base, then we multiply it. Look at this. What was our breadth here? Our breadth is the same as the height, then we multiply it with the height. So I want to give you an example again, using the same units. We have the base. Our base here is 5 centimeters, meaning that we're gonna have 1/2 multiplied by 5 centimeters multiplied by our height, which is this height here, which is going to be 5 centimeters, which is going to be half of 5, that is 2.5 centimeters multiplied by 5 centimeters, which is equals to 2.5 multiplied by 5 centimeters, which give us now 12 6.5 centimeter squared. Like I said, if we calculate the actual area of a square and we divide it by 2, we are going to get the area of a triangle, because a square is made of 4 right angles triangles, whereas the triangle is made of 2 right angles triangles. Okay, I move on. I move. And that's it. Those are our 4 core shapes. Okay, meaning that if we want to calculate the area of a right angle triangle, we can divide everything here by 2, because a triangle is made of 2 right angles triangle. Okay, now we can move, and then I want to proceed to do the calculations now. Okay, let's go down. We still have the papers. Let's still have the papers here. Right, let's treat some examples now. Okay, let's say you are given this shape here, You're given this, this, okay, and you are given 70 centimeters, you are given 90 centimeters, and then you are given 500 millimeters, you are given 500 millimeters. Okay, then the question says calculate the area of this. Let's say this object here is a table. Okay, this is a table. So now our question says calculate the area of the table. Okay, so we need to know in which units. Okay, so let's calculate this area in centimeters. Let me write it down here. Calculate the area of the table in centimeter squared. Okay, now let's check which object or the shapes are we given. Okay, so what we can see is that we have a right angle triangle 1, we have the right angle triangle number 2. Okay, so the one in the middle now, that means we have a triangle, because if we can check this side is not equal to this side, meaning that is not a square. Okay, because this side is not equal to this side, that means this is a rectangle. Okay, so I'm just going to use different colors to do something here that is gonna help us. I want to show you that we have 2 right angles triangles here. So what can we do to calculate the total area of this table? Okay, and then we only know about the formula of calculating the area of a triangle. Okay, so what are we going to do in this situation? Okay, so that should not be a problem to you, because you've got me. I'm going to explain to you what it means. and then how you should approach it. Okay, so what we can see here is that we have two right angles triangles. I'm going to emphasize it. Two right angles triangles, and we also have the rectangle in the middle. Okay, we have the triangle in the middle. Even though they seem not to be the same because of my drawing, it's fine. It's fine. We know the meanings now. We can see what is happening. The drawings is not a matter. Okay, right, let's go back to the business now. Now if I take you for a ride now and take you back of what we just did right now on how to calculate the area of a triangle, let's start with it. Let me reduce the size of my pen. Right, if we need the area of a triangle right now, we must start with the triangle. Hey, my dot. Okay, the area of triangle. Because why am I saying triangles? Because if we can combine the two right angle triangles we're going to end up having a triangle. Okay, now how do we calculate it? The area is equals to half base. What am I doing here? Half base multiply half base. Okay, let me write it nicely, man. I don't know what I'm doing here. Okay, we're gonna say half base times height. Okay, so if we check on those two right angle triangles, which side is our height? Our height is 70 centimeters and our base is going to be 500 millimeters plus 500 millimeters, because now we have to combine them. And then what are we given? We are given that from this point to this point is 500 millimeters, and from this point to this point is 500 millimeters. So we have to bring them together. Now let's start by doing that. So our base is equals to 500 millimeters plus 500 millimeters, which is equals to 1000 millimeters. Okay, but then look at our area now. We have to calculate the area of this table in centimeters squared, meaning that these units have to be changed. Okay, so we're going to check the relationship between centimeters and millimeters. Okay, so it says 1 centimeter is equals to 10 millimeters. Therefore now we can convert the millimeters into centimeters. Okay, so we are now having what? We are having the right hand side. We are having the right hand side, which is 1000 millimeters. So we are not given the left hand side. So we cross multiply. Question mark multiply by 10, that's going to be 10 question mark, which is equals to 1000 multiplied by 1, that is 1000. So we're going to divide both sides by 10 because we are looking for the value of the question mark. So this 10 is going to cancel this 10. Then for our question mark is going to be, this will cancel this. That will be 100 centimeters, because the question mark is on the left hand side and the units on the left hand side is centimeters. Okay, meaning that our base, we have converted our base. Now when we come back to our formula, now we're going to have 1 over 2 multiplied by 100 centimeters close brackets multiplied by our height which is 70 centimeters. So this is going to be 50 centimeters multiplied by 70 centimeters, which is now going to be 50 multiplied by 70. Okay, 50 multiplied by 70, that is going to be 3,500 centimeters squared. Okay, and now we are not done. We did not calculate the area of the table, so now we are going to calculate the area of a rectangle, because our table is made of two right angles triangle and a rectangle. Two right angle triangle and a rectangle. Okay, so how do you calculate the area of that? Is the length times breadth. So in this case, our length of this rectangle is 90 centimeter and the breadth is 70 centimeters. So it's going to be 90. There's no need to convert here because all your dimensions are given in centimeters, which is equals to 90 multiplied by 70, which is going to be 6,300 centimeter squared. Okay, so now for us to have the area of the table, we'll therefore say area of the table is equals to 3,500, which is the area of the triangle plus the area of the rectangle. Okay, which is 6,300 centimeters squared, which our answer now going to be 9,800 centimeter squared. Okay, then that will be our answer. We first calculate the area of this two right angles triangle by combining them, and then we also calculate the area of the rectangle, and then we combine them. Okay, so I want to show you another example, but let me go to another paper. How many papers am I left with? I'm left with one paper, so I'm gonna do two more examples, and then that will be the end of the session. Okay, let me check this one. Okay, let's say you're given this let me take blue. Okay, given this, let me take a red one now. Let me take a red one and do this. Aish. Right, so let's say this is what can we call this? Okay, let's say this is a coin, but this type of a coin that you have, it has a hole in between. It has a hole here in the middle, but the hole is taking the shape of a square, and then the diameter of this coin is equals to let me check here, 3 centimeters, meaning that from this point, when they measured from this point to this point, is 3 centimeters, and one length of the square, one length of the square one length of the square is 0.9 centimeters, meaning that one side here, because this is a square, it is 0.9 centimeters. Okay, so the question now comes and say calculate the area in centimeter squared. Okay, so how can we calculate the area of this coin in centimeter squared? Bear in mind that in the middle it is a square, that is a hole, meaning that you can even put a finger there. You understand? So there's a hole there. That means that hole doesn't form part of this coin. Okay, so now we're going to start with the full circle, because we cannot calculate the area excluding this. If we calculate the area of a circle, it means that this space is going to be included in between. You understand? So what we are going to do first, we're going to start with the area of the circle, okay, which says pi r squared. And when we check here on our dimensions, we are given 3 centimeters as a diameter. So we don't have the diameter in our formula. So we're going to say radius is equals to diameter divided by 2, which is 3 centimeters divided by 2, which is 1.5 centimeters. Meaning that our radius is 1.5 centimeters. So our pi is substituted by 1.42 into bracket 1.5 centimeters to the power 2, which is equals to, let's see, 1.5 multiplied by 1.5, which gives us 2.25 centimeters squared, multiplied by 3.142, that gives us 7.0695 centimeters squared. So if we round off, I will round off at the last answer. Okay, so this is the area of the circle. So we can calculate the area of this square. So the area of the square is equals to side multiplied by side, which is equals to 0.9 centimeters multiplied by 0.9 centimeters, which is equals to 0.9 multiplied by 0.9, which is 0.81 centimeter squared. Okay, now what are we going to do? So the area of this coin is that we are now going to take out the area of the square so that we can now remain with the coin. Okay, so we are going to take the area of the full circle, which is 7.0695 centimeters squared minus 0.81 centimeters squared. Okay, minus 7.0695. So it gives us 6.2595. So we can say 6.26 centimeter squared. That will be the area of our coin. Okay, let me look for more combinations. Okay, let me do the last combination of the shapes. Okay, let's say here we have a house. Let me draw the plan of that house. The house takes these shapes. Okay, whereby here we have, I'm going to use the imperial system units now. We have 20 feet, and then here we have 10 feet. Okay, and the question says calculate calculate the area of the house in feet. Okay, remember the feet are the distance units used in imperial system, okay, not in the metric system. So what are we going to do now? Let's analyze our house. When we look at our house, shape A is given as a semicircle, shape B is given as a rectangle. Okay, so we can start by calculating the area of the rectangle. Okay, area of the rectangle. So the area of rectangle is equals to length times breadth. So in this case, our length is 20 feet and our breadth is given as 10 feet. So our total area of the rectangle is going to be 200 feet squared. Okay, then we will proceed to calculate the area of a semicircle, because now we are not given the full circle. The area of semicircle. Okay, so we're going to say area is equals to pi r squared divided by 2, which is equals to 3,142. Now the question is, are we given the diameter or the radius here? We are given the diameter, so we have to calculate the radius, which says diameter divided by 2, and our diameter is given as 10 feet. So you're going to say 10 feet divided by 2, which is equals to 5 feet. Okay, then we come to substitute it in terms of this r. Then we're going to write 5 feet to the power 2, divide everything by 2, because we have the semicircle. So you're going to have 3,142 multiplied by 5 squared. That gives us 25 feet squared. Divide by 2. Okay, so we're going to have 3,142 multiplied by 25. That gives us 78,55 feet squared. This was the area of a full circle. Then we divide it by 2, and that gives us 39,275. Okay, this was 200. Then we go back to calculate the area of the house. Therefore, area of the house is equal to area of the rectangle, which is 200 feet squared, plus 39,275 squared feet squared. Feet squared, which is equals to 239, let's round off to 2 decimal. That is going to be 28 feet squared. And that's how we can do our area. Okay, so this is going to be the end of my lesson for today. I will be coming back again to show you how to calculate the surface area and the volume, and from there we're going to be treating previous question papers. But if you still want the private mentorship, make sure that you ask for my numbers in the comment section, and I'll forward you my number so that I can tutor you privately and show you more details about Maths Lit. Okay, so if you have watched this video up to this far, thank you so much for doing that, and I hope this video is gonna help you to achieve that percentage that you are willing and you have the ability to achieve it in your examinations. Thank you. Have a blessed one.